Okay, guys, let's go ahead. So let me start sharing my screen. And we're gonna do it. Okay, yeah, so my name is Sergey and I'm founder of SmartyKit, as you know already. So we started a weekly series of webinars, and today we're going to talk about Woz operating system. This is engineering piece of art of 256 bytes only. And it was main software that was used by Apple I, the first computer of Steve Jobs and Steve Wozniak. Okay, so we're going to talk again about Apple I architecture. And so I see Yannick that was yesterday, so he probably heard about this, but anyway, we would talk about this for the others. Also, we're going to talk a little bit about operating systems. We're going to recap what it is, and we would talk about Woz operating system features, so we can check them in Emulator. And also, we would review code of Woz OS in Python. That is simplified version that I wrote to explain how it works. And also we're gonna skim the code of 6502 assembler version. And also I'm gonna show you pictures of SmartyKit. That is really beautiful. Okay, so let's go ahead. So again, Woz OS was running on Apple I. So Apple I was presented in 1976, ran at 6502 CPU at 1 megahertz, and had text mode only. That was very specific feature of Apple I, because Apple II and many other computers, as we know, they have graphic mode where we can play a lot of different sorts of games, and when CPU can turn on or turn off some specific pixel. But when we talk about Apple I, it cannot do this, and it just can print some charts. And also today we've posted on our Twitter a very interesting article by Ken Sheriff, who is really guru of reverse engineering of different sorts of chips. And he covers in his article, he covers 2504 shift register that was used by Apple I for terminal for video output. And so it was 6 chips like this, not ordinary video RAM, but shift registers. So that's why it, like all the scrolling was done just by using shift registers, and that is really cool. You can take a look in our Twitter. Okay, so let's take a look at this big board, the Apple I board, and I marked 2 programmable ROMs here. That's just the only firmware on this board. So it's like 256 bytes and 2 chips. So every chip is 256 by 4 bits. So together they make up the Woz OS ROM. So the other is just there is no any ROMs here besides this. So we can see where it is located. Okay, let's talk a bit about architecture of Apple I. So it's very straightforward, and Woz OS needed to work with this. So it has CPU 6502, it has memory 64 Ks available, it has input and output. Output is display, char out, you can do one char at a time, and char in for keyboard. And so Woz OS needs to manage this, so to communicate with this hardware and software. Okay. Yeah, and what it is, if we talk about operating system, what it is, so we refer to the classical book of Andrew Tanenbaum, Modern Operating Systems, and he says that it's a bit different to explain what operating system is. But anyway, it's some special program that runs in some special mode with all the privileges available. And in general, it runs the other programs and can then shut them down, and because no other programs can shut down the others. But from the user applications point of view, you can see the stack on the right is like on the very bottom, it's hardware. Then it goes operating system, that is a kind of a layer that communicates from with the hardware, and from one side, and it's also some kind of a driver for user interface programs that in its turn help user apps to have abstracts from all the previous layers, and just to use simple functions like, I don't know, printf or whatever. It doesn't need to care what kind of terminal was used, what kind of chips was used there, and it just have very high level of abstraction. So operating system, from one side, it's interface for the other programs, higher level programs, and from the other, it manages hardware resources and works with them. And taking a look at the memory map, we can say that this operating system is just very, very high in the address. It's located at address FF00, and so like only 256 bytes. So like it goes from FF00 to FF. So here you can see it's right on the higher address segment. Okay, yeah, what kind of modes it has? Woz operating system. What can be done with this? So first of all, it can examine some memory area, some memory block. So it's you could either can enter some address. It's for hex alphanumerics, and if you would add dot between them, so it would denote that you need to enter the second address, and it would be the block from starting address to like start and destination address. So all in between would be examined and printed on the screen. Also, it has store mode to if you need to change something. For example, if you would write some simple program, write in machine code to write to the memory cells, and then you can run on them. And run is for sure the most practical command for a user, because in general we use computers to run some software on them. So for Woz OS, you cannot run, for example, like you don't say like I run Word application or Pages or Numbers, or you cannot run Chrome or something using some kind of names. All you need to know is address where this program is located, and before running it, you need to load it somehow. In Apple One story, we discussed this cassette interface that helped with this, with loading programs. But also you can type them in using store command and then run it from this address. So this is basically 3 types of modes. And now we can, I can share the other screen, and we're gonna check. Do you see this? You see the emulator screen?
Yes, we do.
Okay. Okay, yes, so we're gonna go and reset it, the emulator. So it starts with the post message, and now we're ready to input our command. And for example, we have this hard pixel art, so at FC00, and we can examine, for example, what is FC, for example, FF. Examine these blocks. It's gonna show us what kind of bytes are there in the memory, and you can see like 8 bytes in line, and so just like you see the addresses are just like counting, and at the end you like FCF8, and so by the FFFF. So then we can do the same, adding R, which means that we're going to run this program, and yeah, it starts to run this. Program. Also, we have, for example, this Hello World program. So we can run this, and also what is we have very classical one program is Woz face. So it is located, I think, here. So we're going to start it. Yeah, so it's here. So this is the program from our splash screen for this webinar. So it is located at F000. And so at first it shows the first byte, like A9 is the first code of this program. And it was specific for Woz OS and for its programs that they basically don't have exits you cannot really stop it. This program, you can just reset the computer with a button, and this emulator also could be reset like this. For example, I go to reset, and then it's just like starts over again. Okay, so now I think you got the idea of how it works. Now let me get back to my presentation. Where's my presentation? My keynote. Where's my keynote? Okay, yeah. Let me share my screen with it. Okay, let's get back to our presentation. Yeah, so now we know all these three modes. Okay, so what it is in a nutshell, if we're talking about how it works. So let us check Python version of its code. So let us go to share. I'm gonna share the screen with my code. Yeah, here's like Woz OS. You should see it on your screen. Okay, so basically, also to make it simple, I just like also create two classes. One is called hardware interface, and it just like it contains all stuff that is related to hardware. And the second is user interface, and basically the simplified version of infinite loop that we have in our Woz operating system is like this. So basically, we create like one instance of hardware interface, one instance of user interface, do some printing just to see that it's started. So first of all, like we need to init our hardware. In assembler version, it would be much more clear what's going on. But basically, you just like set up the chips that are used as interfaces, just like write some commands to them. And then you just enter some loop. Here, I just like limited this number of loops by the number of 5, but in real hardware, in real Woz operating system, it's just infinite. You can just go until you just like press reset or turn off the power. Okay, so what it is in this loop. So first of all, it reads user input. So you have seen that I've entered some commands using keyboard, and so just like it prints them on screen, and it reads them in text buffer. Well, when it just like it gets the carriage return, it understands that it's okay. User have entered everything. The string is ready to be processed. So the second steps, the second of this algorithm is to parse this user input in order to understand what command it was. And doing this was code basically tries to find these dots and just to understand whether it's block mode or just like single cell mode. And it tries to find letter R in order to understand that user wants to run something. And also it reads colon in order to understand that we're trying to store something. But anyway, it's just to simplify the algorithm, we can say just like it processes this string in order to find some action or some command to execute. And the third step is very simple. We understand what we need to do and we send command to hardware in order to execute this action. And this could be read something from memory. So in this case, we're trying to get something from a read-only memory or random access memory from physical device. If we want to store something, it also some physical device that is affected. We write something to a memory cell or memory cells. Or if we try to execute something, it also means that we change the state of CPU, given its command to go to some specific address location, load it into program counter, and start from this point to execute what was written there. So this is the very simplified version of what it is inside. We can take a look at hardware interface version. So in this Python, we just in it, we just print that we're initializing something, but we're going to check this 6502 version. I can show it what's going on. If we execute here, it's also some plug, some dummy that we print something, but I've explained to you what's going on. But what is very, very interesting and specific for Apple One and the Woz operating system, it has two distinct functions here that are connected to hardware. It's echo, so it prints some chart to a terminal to display, and so it provides this function to all the other programs, this operating system. So if we write something like hello world, as we do on our Tuesday webinar, so we use this function. So we don't really need to understand how this terminal is working. We just call this function using its address, and that's it. So yeah, only primary is just char that is used, and it uses it from register A. And the second is to get some input from the user. So it's called here get line. So it is a sequence of getting chars from keyboard and sending them to a text buffer where you can get them and process them, this string that was saved. So basically, as in this schematics of architecture, you see you just basically can do two things with this hardware. So you can just print something, some char and some chars, and you can get them from keyboard, and that's it. You cannot play music or anything like this. So you don't have a lot of options. You don't have any network connections, so you cannot really send something here. So this hardware is not able to do this. So it's very simple, and that's why it's good to explain on bare metal. User interface is just this idea is to print what your user is trying to input, and also to understand what kind of mode was used, like you're examining something, storing and doing it in block or not. So by default, it has variables to save this address, to examine and to store. And also it by default it's examine mode. It treats input and it parses input, and if it sees the dot, so it understand that it's a block mode. If it sees a colon, so it goes to store mode, saves something in memory cell. If it sees R, so it needs to run something specific address already saved in a examine address. So it is very high level explanation of what's going on. Do you have any questions about this Python code and how it works? If yes, you can just turn on your microphone and ask me. Now we go next. Okay, anyway, you can just ask something in our Discord channel. Okay, let me share the other code. This 6502. Okay, so here we are. So this is original Woz monitor for Apple One in its like 6502 version. It was printed. Its listing was printed in Apple One instruction, and it is also in our Discord channel. You can download it. So its listing is there with all these comments. Yeah. So what we see here? We see here it's some constants that are very hardware specific, and this is key feature of different sorts of drivers in operating system, because we specify exactly what was hardwired in our devices. So here you see like this addresses also that was used for variables, like L means low, H means high. So together they like these 2 bytes. They make the four nibbles and for 4 digits address, full address of for any place, 64 kilos of memory, and the same is like stored LH, so the same LH, and so here you see these addresses of variables used in this operating system. Okay, so here you see the very specific to hardware tool things like on line 19, you see this input text buffer address, so where it stores the user input, and what you can see here, it's like it goes up to 027F, and so what is the max? What is the max in user input string length? So the question is, if we have starting address of 0200 and the last address is 27F, 027F, what is the max user input that is supported here? Just to understand. Anybody can answer this question.
F.
Yeah, but I mean in decimal. Yeah, sure, it's 7F. Yes, so 7F, it's almost 0. Okay, so F equals to 15, right? So 7F is 7. Something like this, yeah? Looks like this. Okay, yeah, it's 7F, whatever it would be in decimal. Okay, so then we see this input and output for keyboard and display. This registers then ports. So they're also here. You can see that they're hardwired. I mean, they're hardwired on in Apple, an Apple One circuitry, and see here you just like you also see this is constants. So yeah, this is also very typical for all drivers and low-level programming code. Yeah, so here's initialization code. We just like the clear interrupt flag, decimal, arithmetic mode. We load specific values to display controller in order to to help it start working. So we need like this initialization operations here. And so then it goes like pretty much as we discussed in the high level version. And also what is specific that, for example, in Python, we don't really care about these conversions of numbers. But here you see that we need to do a lot of this because numbers that are stored, for example, in a register, numbers that should be presented as a char, it's very different because chars printed, they are encoded by ASCII code, and ASCII code should be sent to a display, and vice versa. If we read something from keyboard, for example, we read 9, 9 would be in hex, it would be 39. If we talk about ASCII code, and then we need to convert it to real 9, so we need to find out that we need to subtract the 30 and so on. Here, for example, you can see like in print hex subroutine, you can see that we adding like this ADC, like add with carry, like 6 to the value in order to work with these hex letters. So that's why it's a bit more complicated, because even simple things like printing some chars is converting from simple from binary code to this ASCII code, and it needs like to this here you need to do it like in 2 sides. But anyway, like here, like run is very simple. It's just one line. You can just jump to the whatever was saved at the address of XAML. So if you do this, so it's like it loads not just low but high address also, and then goes to the value of stored at this address. Okay, so this is the short review of our code. Let us go back to presentation. Let's get back to. Okay, yeah, so we took a look at this. So it's 65 version in assembler, it has a lot of hardware specific constants and also conversions, number conversions, that makes it listing like a kind of a not so easy to read, but the functions of this is pretty much the same as for the Python version. And so this is pretty much it. So it was short review of what was operating system of Steve Wozniak and how it works. And also I plan to show you some beautiful pictures of SmartyKit. And here's my daughter, she's assembling our kit. And you see this beautiful instructions remade from the real Apple One instruction. Also, we have this ASCII art available as our driver update. If you have already a SmartyKit, you can just download it, and also have this Smarty logo as the ASCII art. And also we have a Steve Jobs garage there, so you can check our Twitter with this. And so subscribe, join our Discord, follow us on Twitter, clone our code at GitHub, because you can play with Steve Wozniak's operating system using Emulator that is already available on our GitHub, and it's real fun. Also, you can watch our videos on YouTube. And we'd love to hear if you have some questions. Just please go ahead if you have any.
I have a question.
Sure.
You mentioned the revised or redone Apple I manual. I apologize if this information's on the Discord channel, but is there a way for us to obtain that easily?
It's these instructions, they were redesigned by a guy from Germany. His name is Armin, and he sells them online. So you can buy it from Armin. Okay. This is the way how we got it. For us, they are printed on the very beautiful paper, and yeah, they're available. We plan to maybe to do some affiliate program with Armin in order to help you to save something from this purchase.
Yeah, that'd be great if you had a link somewhere on your site to that manual. That'd be terrific.
Yeah, we're gonna do this. But now I can just send you the link in order to check this. But yeah, we will work on this affiliate program.
Thank you. And thanks for everything you've done, by the way. This is super helpful.
Thank you.
And super interesting. I grew up in near Cupertino, right near where Steve went to high school, and kind of watched Apple grow up around me. And actually, I still have an Apple IIe. But I never got into this level of understanding. And thanks to your work, it's all making sense now. So thank you.
Thank you. And so you already our subscriber, right? Or you pre-ordered something?
I don't think I am, but I know I get your emails, and so maybe I am. But I guess I would subscribe through the contact at SmartyKit.io, or
yeah.
Oh no, right there. I see it. Yep.
Okay.
Okay,
right thank you. Thanks for your feedback. Do you have any other questions, guys? Abdulaziz, maybe you're gonna want to ask something.
Yes, Mr. Sergey. How are you?
Yeah, please go ahead. Yeah.
Sorry for my emails. A lot of emails.
No problem.
I wanted to ask about Steve Jobs. Some people said that Steve Jobs is just a marketer. Is that true?
I cannot say that I'm a kind of some kind of a guy that can, but
not software engineering or something like that.
Well, I cannot say that I'm a kind of can say a lot about his biography and make some kind of points on this, but as I see, at least in documents, we can say that on Apple I he was a project engineer. It's written like this, and Steve Wozniak was a real engineer. So it was like I think it was like normal distribution of kind of competences. So for these guys, so you don't need all guys to be engineers or software engineers in your team in order to build something. So my point of view, he for sure was much more about organizing all stuff, and was for sure was the engineer in their team, the guy who invented everything and started to create this culture because if you take a look at the, for example, Apple on board, you see that it's not just a big bunch of chips, just like randomly located at this board, but they're just like all organized in rows and columns, and everything is just done to be like a kind of a look like a piece of art for that time. And for sure, engineering part was responsibility, and Jobs was the guy who was trying to make first of all think about business side of this. That's my vision.
Okay, thank you so much, Mr. Sethi.
Thank you. Sabo, do you have any questions? John, maybe you.
Sergey, how did you get started with the early Apple computers?
Sorry.
How did you get your start with early Apple computers?
Frankly, first of all, I've started with the Z80 and ZX Spectrum. That was my kind of like kid's dream to build it, because I found out these schematics in one Radio Hobby magazine, and I wanted to build it from scratch. But then, just like I was trying to remake it like when I was like in my 30s. But then I found out that Apple I is much more cool than ZX Spectrum, because 6502 is much more technically like a kind of good. It's also was like Z80s were very famous in that time, but anyway, 6502 it's much better from many points of view. You don't need so many buffers to work with this data bus and address bus. It uses like universal address space for ports and everything, because the 80 it has separate lines for this, and it complicates the schematics. And so I fall in love with this, read a lot about this, read a lot of books, articles and so on, then decided to redesign it, and then sent it to Woz, and Woz say, wow, it's cool, it's amazing. So he took part in our webinar, and yeah, and it all started to to grow, and we presented it at CS in Las Vegas, and also many people were coming saying, wow, Apple I is so cool. So yeah, and so that is how I just like became a kind of one of the guys who lives in this Apple world, because I didn't have any Apple IIs for like many people I know had like you, for example. Yeah, but so I came like from the engineering part, so like trying to rebuild it and comparing different architectures, and I really understood that it's just was really cool.
Cool, thanks.
Thank you guys. I think if you don't have any other questions, it's all for today. But anyway, we just like post a lot of stuff to our Twitter. Now we plan to remake our online instructions, in order to make them even more intuitive and fun, adding stories like videos to help you assemble this. And yeah, you can also ask any questions regarding Apple and technical stuff and business stuff in our Discord. So it was my pleasure to see you today. So thank you guys.
Thank you for putting this on.
Thank you.